In this demo, we will show how we can apply the approach proposed by the S-OGSA architecture and the technologies developed in the context of the OntoGrid project in order to enhance the provision of access control mechanisms in the Globus Toolkit 4 platform. The figure shows the general architecture of our approach, which will be explained in detail later. We assume that the audience is familiar with the terminology used in authorization: policies, policy decision point, policy information point, policy enforcement point, and so on. The video shows several command line consoles displaying information about the different services involved in the demo. In the upper right red console, we have a GT4 container with the service that acts as the policy decision point, or PDP, in the authorization scenario. The PDP will decide whether a service requester can access the resource operation or not. In the lower right green console, we have a GT4 container with the service that acts as the policy information point, or PIP. The PIP will provide the information needed by the PDP in order to decide whether to give access or not to a resource operation. This PIP is implemented by means of OntoGrid's semantic binding service. In the lower left yellow console, we have a GT4 container with an ontology service which will provide access to ontologies describing the application domain, user roles, information about car drivers, accidents, etc. In the middle left blue console, we have a GT4 container with the policy enforcement point, or PEP, which will intercept the requests to perform resource operations, send information to the policy decision point, and act according to the results provided by it. Finally, the upper left black console represents the user requesting access to the resource operation. First of all, we introduce into the semantic binding service information about the user who will be requesting access to the resource operations. Normally this information would already be available in the semantic binding service, but we include it here for completeness and to demonstrate the entire metadata lifecycle. The user wants to access the Get Insurance policy operation of the resource that represents a car insurance company. The user presents his digital certificate so that the system can identify it in the context of its virtual organization. As we can see, the policy enforcement point, the blue window, intercepts the call to that operation and delegates the rest of the process to the policy information point proxy and to the policy decision point proxy. The PEP uses the PIP proxy to get to the semantic binding service, retrieving the information that it contains about the user requesting access. He has had only one accident in the past and has been insured by a company. This information is sent back to the PEP. Now the PEP uses the PDP proxy to send an XACML request to the PDP. This request contains information about the operation being requested and about the user, as obtained from the semantic binding service. The PDP receives the XACML request and begins to process it. First, it gets the insurance ontology from the ontology service. Then, using the ontology and information contained in the XACML request, it classifies the user using a reasoner in order to find the role that the user plays in the scenario. Here the driver is classified as a good reputation driver. The PDP then looks up in the operation role mapping table and reaches the conclusion that the user can be granted access to the resource operation he was requesting. The PDP sends back an XACML response to the PEP granting access to the user. This demo has shown an example of how a middleware component of a platform like Globus Toolkit 4 can be implemented using a semantic approach, giving more flexibility in the implementation of the business rules for authorization. This is not aimed at replacing existing PDP components, but provides an alternative way of implementing them. The demo also shows how different types of services can coexist, as proposed in S-OGSA. Semantic ignorant services, such as the PEP, services that are semantic aware but incapable of dealing with semantics, the PDP and PIP proxies, services that are semantic aware and capable of dealing with semantics, the PDP, and semantic provisioning services such as the semantic binding service, the ontology service, and reasoning service.